All right, in this homework, they are asking us find the exact value, find the expression for sine of phi, cosine of phi, and tangent of phi. All right, so we have a right triangle. That means we don't need to use law of sine and law of cosine. So this is great. Correct. So sine is opposite over adjacent. Agree? So this is an angle. The sine is opposite over hypotenuse. Hypotenuse is a side front of the 90 degrees. So this is hypotenuse because it's the longest side, also is a front of 90 degrees. So for sure R is hypotenuse. So for sine, opposite to this angle, so this angle has two sides. One of them is here, another one is there. The one next to it is adjacent. The one front of it would be opposite. So it will be opposite Q over R. Cosine of this angle will be adjacent over R, and tangent is opposite Q over adjacent. And that's it. That's okay, Lindsay. As long as you don't forget, that's good. So when I give you guys a right triangle, you guys should be excited because no law of sine and law of cosine. Any other homework question?
I'm not sure if you went over this one already, but it's chapter 9, section 9.2, question 5 through 8.
Yeah, I post this on the YouTube. I sent a link last night.
Okay, thank you.
That's a very good question that you should know it.
Okay, thank you.
Give you, I mean, I like to talk about it. This is here. Well, it doesn't make sense, but what's happening, I give you guys, I'm going to just explain quickly because that's my favorite question. What we have sine of theta equal to 1/4, and theta is between pi half and 0. So this is given, and they're asking us what is cosine theta and what is tangent theta, correct? So in order to solve this, we need to draw a circle. So we draw a circle. That's not a circle. We draw a circle, and we have x and y, correct? So now our job is to see in which quadrant the theta is. They said theta is between 0 and pi half. This is 0, and that's pi half. That means on this quadrant, we need to draw a triangle. So I will randomly, I'm going to call this one theta. Why did I draw it on the first quadrant? Because they're saying theta is between 0 and pi half. So I randomly make a theta, and then I will create a right triangle. All right. And the right triangle, so now we have sine of theta is 1/4. So on the right triangle, same as previous question, sine is opposite over hypotenuse, correct? So this can be 1 and this can be 4 because sine of theta is opposite to theta is 1. So this is 1 and that's 4. Or your note sheet, you should have sine of theta equal to y over r, cosine theta equal to x over r, and tangent theta is y over x. This is same as opposite or adjacent over hypotenuse. But this is more direct. Anytime you're dealing with this question, so sine is y over r, so that means 1 is y and r is 4. That's what I put. Then we use Pythagorean theorem to solve for the third length sine. So Pythagorean theorem, we have 1 squared plus x squared equal to 4 squared, 1 plus x squared equal to 16, x squared equal to 15, x equal to plus minus root 15. So we have plus and minus, but because we are in quadrant 1, x should be positive. So I will get radical 15, so not negative. All right. So now we are done. I mean, not the easy part. Cosine theta, in your note sheet, we have x over r. So this is radical 15 over 4. You're done. Tangent theta is y over x. This will be 1 over root 15. It seems like in your homework, they want it like this. You don't need to irrationalize it. We usually get rid of the radical on the denominator, but you can keep it like that. All right. Any other question? This is my favorite question, so make sure you understand it for the exam. Any other homework question?
I don't know if you already answered this one, but chapter 8, section 8.2, question 6.
Yeah, this is what I solved on the last. So question 8.1, correct? 8.2.
Yeah, 8.2.
Yeah, you use law of cosine. This is, I solved this one in last night's YouTube video. You have to use law of cosine. Please watch that video. I mean, I have it right here. That's what I solved. So this is a video on the YouTube. I sent you guys a link last night. Use law of cosine. Any other question?
Could you go over the first one, like the first question?
Which question?
Chapter 7, section 7.4, number 4.
Andrea, are you okay to look at the video? Yeah. It would be same. I mean, the way I'm going to explain it is going to be same as what you see online. So, chapter 7, what section?
Chapter 7, section 7.4, question 4.
Question. They're saying find the amplitude. So we have y equal to 10 minus sine of t over 5. Correct. So find the amplitude and midline. So when we have a periodic function, let's say we have, this is a periodic function. The period is what it repeats. For example, from here to there, that's the period of the graph. And this is the amplitude, A. And we also use a line, the line that cut the graph. For example, if this is a periodic, this will be the midline. Usually it's like y equal to something. So in order to do this, we simplify this. This is like a 10 over 5 minus 1 over 5 sine of theta. So amplitude here will be 1 over 5. So A sine of t, this absolute value of A is an amplitude. Correct? So there's a formula. And 10 over 5, which is 2, which is 2 minus 1/5 of sine of t. So if this is a graph of sine, y equal to 0 is a midline. Now you add 2 units up, so you shifted 2 units up. This is going to be like this. So the midline going to be y equal to 2. All right. So 1 over 5 is 0.2. We can put 1 over 5 or 0.2. Amplitude not going to be a negative number. Any other question?
I don't know if you've done this one already, but it's chapter 8, section 8.2, question 2.
Doing all the homework, yeah. 8.2, question 2. Solve for x. Did you try working on this, Lindsay?
Yeah, and I input 2 different answers and I got them wrong.
What did you get? What is the...
I got 1.732.
So what I have is like this question, correct? This is chapter 8, section 8.2, number 2. So they ask us to solve for x. So when you see a triangle, we would love to don't use law of sine and law of cosine. So we would like to make, but in order to don't use the law of sine and law of cosine, we need to have a right triangle, but we don't have a right triangle, correct? So we need to use, so we don't use the basic of sine and cosine. We have to use law of sine and law of cosine. Before we use law of cosine, we try to use law of sine. Can I use law of sine here? Lindsay, can I use law of sine?
No.
No.
Yes.
No. We try. We say sine of 26 degree over x equal to sine of, for example, a over 6 equal to sine of b over 4. So this is the entire law of sine. Any two equation you pick, not two equations, any 2 of them you pick, you see there are 2 unknown. A is unknown, x is unknown. If you take these 2, a and b are unknown. If you take the first and last one, you see b and x are unknown. So we cannot use law of sine. We use law of cosine. And at the beginning, I mean, if you have, at the beginning, when you see a question like this, you should see, oh, we have to use law of cosine. Law of cosine said this side is square. We have x squared equal to 6 squared plus 4 squared minus 2 times 6 times 4 cosine of 26 degrees. The way you, so this is like a 36 plus 16 minus 2 times 6 is 12. 12 times 4, 48 cosine of 26. 52 minus 48 cosine of 26. So you need to be very careful with the way you're going to calculate this. This should be first. You have to calculate this one. Also, you need to make sure that your calculator's mode is in degrees, not in radians. So after making sure those are okay, so you do this, then subtract from 52. This will be x squared, then x will be radical that. It looks like gives you, for this particular question, you get 2.976. They said 3 decimal places, so you need to use 3 decimal places.
On a calculator, how do you change from radians to degrees?
Google it. But you, I don't know what calculator you have, but there should be a button said mode. It should be a button say mode and make the mode from radian to degrees. If you Google it, it will be much faster. Okay, but make sure you have that set. All right, guys. So we have chapter 10 and 11 left. Chapter 11 has something new that probably you've never seen it, but chapter 10, what we worked on chapter 1 and 2. But you were dealing with more advanced function and you need to apply advanced algebra to simplify. We talked about inverse function. For example, we have f is 5, 2, 3, 8. If I ask you guys what is f inverse, we learned that we switch x and y, correct? F inverse will be 2, 5 and 8, 3. If I give you guys a graph, you're able to make an inverse of the graph by reflecting. Let's say we have a graph like this, and I ask you guys, graph the inverse. We're gonna make a line, y equal to x, and we reflect this to this line, and we will get f inverse. Similar to that. All right, and we learned about one-to-one function. One-to-one function is a function that the inverse of that is a function as well. For example, this is g of x. Is this one-to-one?
No.
Very good. It's not one-to-one because in order to know it's a one-to-one, we learned the horizontal line test. If you cross more than 1 point, this is not one-to-one. That means if you graph the inverse, this is going to be inverse, for example, then the inverse of that is not a function. F of x equal to x squared, g of x equal to 5x. So let's say this is factory for f of x. Like a 2 goes inside, we get 4. 5 goes inside, we get 25. So, and there is another factory on top of this mountain. This is g of x. If 1 goes, we get 5. If 4 goes, we get 20. If it's 25, we get 125. All right, there are two separate factory, but we can compose them. We can get the output of first factory and plug it to this factory. So the output of one factory will be input of another factory or relation. So we are composing them. For example, what is G of f of 2? So we learn it like this. This is exactly the same as G or f of 2. Correct? How do we did that? We said f of 2. Then when 2 goes inside, we get 4. So instead of f of 2, I'm going to put 4. Then what is G of 4? Then 4 going to go inside of this. The G of 4 will be 20. We learned this. But in this chapter, we will deal with little spicy look of function. Also, I could ask you guys, what is G of f of x? That means what's happening if I put this entire thing as one factory, what's the relation here? It would be G of f of x.
5x squared.
Okay, so I mean f of x. So if you have a number like this example was simple, we evaluated, we substitute. But on this example, we have f of x. So instead of f of x, I can put x squared. They're asking what is g of x squared? G of x is 5 times x. G of x squared will be 5 times x squared. So this will be the formula of two separate functions. Again, that's the review. Example, f of x equal to 2 to the power of x and g of x equal to x over x plus 1. They're asking us what is f of g of x and what is g of f of x. As you see, now we are dealing with two types of functions that we didn't have any idea when we talked about composing function in chapter 2. Now, when you look at this function, you know this is exponential. And this one is rational function. We will learn this soon. Okay, but we don't care what type of function they are. We should be able to combine them. So f of g of x, this g of x will be inside of f, correct? So what I do, I will substitute this one for g of x. Then we're going to have f of x over x plus 1. All right. F of x is 2 to the power of x. Instead of this x, whatever you substitute, you need to substitute it there. So this will be 2 to the power x over x plus 1. I know it's super ugly, but we don't care. That's a very complex function. What is g of f of x? So f of x is 2 to the power of x. That means we are looking for g of 2 to the power of x. This will be 2 to the power of x over 2 to the power of x plus 1. Question? So g of x was x over x plus 1. X changed to 2 to the power of x. So I just put 2 to the power of x to the power of x. All right. Another example. F of x equal to sine of 4x. G of x equal to radical x. Find the formula for f of g of x. So we don't scare of this type of function, correct? We know we have radical function, we know we have periodic function. If I ask you guys what is the period of this graph, what is the amplitude of the graph, what is the midline, that's different story. But now I'm asking you guys, we have two functions, just combine them. So instead of g of x, instead of the parenthesis, I will plug radical x. This will be f of root x. F of x, we had sine of 4x. Now this will be sine of 4 root x. And that's it, we're done. So this is a formula combining them. F of x equal to 3x squared, g of x equal to 9x minus 2, and r of x equal to a radical 3x. So we have four functions, like we have a city here. We have four different factories. Good. So we would like to input of one of them, output of another one, so we're going to combine them. The question is, what is f m g of x? So we are composing three different functions. We start from this inside, this one. G of x, instead of g of x, I'm going to plug the formula. So it's going to be 9x minus 2. Then we have m of this, then f of that. All right. What is m of 9x minus 2? M of x is 4 times x. If it's x here, you just multiply it by x. Now, if there is something else, whatever is that, if it's a monkey, whatever is that, you will be going to replace it with the x. So this will be 4 parenthesis 9x minus 2, 36x minus 8. So this will be answer of m. So m, it will be this one. Now what is f of 36x minus 8? F of x is 3 times x squared. So this will be 3 multiplied by 36x minus 8 squared. You leave it like this.
What happened to the x with 4x? Because mx equals 4x.
Very good. Mx equal to, if this is a function m, mx 4 multiply with this, correct? If 1 goes inside, we get 4. If 2 goes, we get 8. That's what that factory does. You just multiply it by x, multiply it by 4. Now we are asking us, they're asking us, what is m of 9x minus 2? That means if 9x minus 2 goes inside, the output will be 4 times 9x minus 2. So instead of x, I plug 9x minus 2.
So you replaced it.
Yes, that's what we do, yeah.
Okay.
All right. So now let's go backward. Backward means backwards mean f of x equal to g of h of x. Agreed. So we have two functions, g and h. When you combine them, we get f of x. So there's no problem here. We're okay with this. They're asking us find Sandy, what's going on? Find possible formula for f of x, no, for g of x and h of x. For g of x and h of x. So what's happening? There are two functions here. One of them is g, another one is h. And we compose them, we get function f. F of x is radical 1 plus root x. When you compose them, you get radical 1 plus radical x. So what is g of x? What is h of x? What do you think the function g and h will be here? So we are going backward. Before, we got g, we got h, and I asked you guys what is g of h of x. But now I give you guys g of h of x. G of h of x is radical 1 plus root x. What do you think g and h will be?
H of x can be root x, and then g of x can be root 1 plus x.
Very nice, David, very nice. So that's true. So we might have different type of function, but one of them is this one. So h of x, so this is one option. So he said h of x is root x, g of x is 1 plus, radical 1 plus x. If I compose g of h of x, what do I get? G of root x, this will be radical 1 plus root x. So I get this one, which is true. I mean, there is no way I can explain this. I mean, there's no formula that I can tell you guys to use. Is like you have to try different type of functions. Another one I could say h of x or g of x can be radical x, and h of x can be 1 plus root x. If I compose these two, I get f of x. But I like what David did better. Let's have another one like this. So f of x equal to g of h of x. F of x equal to x plus 3 squared. What do you think h of x will be? What is g of x? Andrea. Any idea, Andrea?
H of x could be x plus 3, and then g of x could be x squared.
Beautiful. I'm glad I asked you. Very good. So h of x, as she said, can be x plus 3, and g of x can be x squared. The cheating way is usually whatever is inside, we can find whatever is inside of the parenthesis or inside of radical. So if x plus 3 is h of x, then x squared will be g of x. Now let's try. G of h of x will be g of x plus 3. G of x is x squared, so this will be x plus 3 squared. Two works. Very good. Now let's talk about inverse. F of x equal to 5x plus 8. What is f inverse of x?
Is it x minus 8 divided by 5?
Very good. So in order to find the inverse, we need to go through a few steps. Step 0, we said we make y equal to 5x plus 8. Then step 1, we change x and y. We say x equal to 5y plus 8. Then in step 2, we solve for y. When you solve for y, that means you're done. So this y, you should have it by itself. That's what we learn. So I'm going to subtract 8. We get x minus 8 equal to 5y. We divide it by 5. Then y equal to x minus 8 over 5. So the last step is you don't package this as an answer. You have to erase this one and put f inverse. You're not going to say y equal to that. We went through some technique to solve for the inverse. So at the end, you need to get rid of y and put f inverse, or put this one over here. So in this chapter, we have the same type of question, but I give you guys a little more spicy equation, like this one. Like h of x equal to 2x plus 1 over 3x minus 2. Find h inverse of x. Good. So I'm going to solve a few examples fast, but you guys will watch this video later to understand it. So step 0, I'm going to make y equal to 2x plus 1 over 3x minus 2. I'm going to change x and y. X will be 2y plus 1 over 3y minus 2. Now I need to have y by itself, but I have two y's. So we're going to factor it at one point. I cross multiply. I will get x 3y minus 2 equal to 2y plus 1. This multiply by that. I distribute this. You have 3xy minus 2x equal to 2y plus 1. I collect y one side. You have 3xy minus 2y. I subtract 2y to both sides, equal to 1 plus 2x. I move this to the other side and move this to this side. Now I have y one side. I can factor the y. I get 3x minus 2 equal to 1 plus 2x. Then I divide it by 3x minus 2. 3x minus 2, I get y equal to 1 plus 2x over 3x minus 2. So the last step is you erase this one, you put F inverse or H inverse. So we solve H of H inverse. Any question here? So the inverse function, if you notice that the inverse function is exactly the same as original function, which is fine. Sometimes it's like this. I mean, the graph will be probably something like that. When you reflect it to the x equal to y, this part will be here and this part will be there. So you will get exactly the same graph. So don't think you did something wrong. We didn't. So algebraically is fine. It happens to be same. J of x equal to radical 1 plus root x. The question is, what is J inverse of x? So first step, I'm going to say y equal to radical 1 plus root x. I switch x and y. X equal to radical 1 plus radical y. Now I have to solve for y. So it's more work. I'm going to square both sides. You're going to get x squared equal to 1 plus radical y. I'm going to subtract 1. I get radical y equal to x squared minus 1. Then I square both sides again. I get y equal to x squared minus 1 squared. So you solve for y. That means you got J inverse of x. In your homework, if they ask you guys what is J inverse of, for example, K, your job is to change this one to K. Make sure what they're asking. If they say T or K, you will substitute that. F of x equal to 1 plus 7x cubed and F inverse of x equal to cube root of x minus 1 over 7. Is this true or false? So sometimes instead of asking you find the inverse, I will ask you guys, I give you another function and ask you guys, are these two functions are inverse each other? Or question like this, are this inverse of that? We don't want to go through all the steps, find the inverse and compare it. That would be too much of work. What we do, we have a shortcut. If f or g equal to g or f, if the answer is x, if you compose them, you get x by itself, that means they are inverse each other. So in this question, I'm gonna find what is f of f inverse of x. If I got x, that means that's the inverse. It would be much easier than going through the solving. So f of cube root of x minus 1 over 7, this equal to, so f of x equal to 1 plus 7x cubed. If it's x, you put x cubed there. So this is going to be 1 plus 7 parenthesis cube root of x minus 1 over 7 to power of 3. This 3 and that 3 will cancel. The radical will go away. We have 1 plus 7 times x minus 1 over 7. 7 and 7 will cancel. 1 minus 1 will go away. You get x by itself. So that's true. So this is a formula to find out if they are inverse each other. Another one, f of x equal to e to power 2x and g of x equal to ln of x over 2. I give you two functions. But my question is, are these two inverse each other? That means if you find the f of inverse of f of x, you will get this. When you find the inverse of this, you get that. So how do we show this? Through the formula, correct? Again, we don't want to find the inverse of f of x and compare it with the g of x. That would be a lot of work. What we do, we see if we compose them, is that f o g same as g o f if the answer is x. If it's like this, then we can say yes. So I'm going to find f of g of x, which is same as f o g. G of x will be inside of x of f of x. This will be e so f of x was e to power 2x. This is same as e to power 2 ln of x over 2. If we simplify that, what do we get? Ella.
E to the ln of x.
Very good. So the 2 canceled. We get e to power of ln of x. What is e to power of ln of x?
Just x.
Shahriz. Yeah, one of the property of log, we said a to power log of log k to base a. If these two are same, the answer is k, correct? Same as e to power ln of k, for example. The base of ln is e, so e is the answer is k. So here there is an invisible base e here, so the answer will be x. So this is a good news. So we got x. But we also need to do this one, composing f, to see if we get x or not. The question is, are these two inverse each other? So you have to do both ways. So what is g of f of x? G of x is ln of x over 2. So instead of this x, I have to put this guy. it will be ln of e to power 2x over 2. What do we do here? So exponents, the property of ln, this will be front, goes here, it will be 2x ln of e over 2. ln of e is 1, so it's gone. We have 2x over 2, the 2 cancel, we got x. So for both of them, we got x. That means it's true, they are inverse each other.
So what happens if you only find one x, but you don't get it for the other one?
Very good question. So you would say they are not inverse each other, but one of them is inverse of another one. But if you will say no, usually the question is, are they inverse each other? You're going to say, no, they are not inverse each other. So as you see, in this chapter is more algebra. So not any formulas here. So f of x equal to e to power of x minus 7. Is this 1-to-1? How can we say this is 1-to-1? One way is graphing, correct? You should be able to have some idea how the graph look like. E to power of x is like this, correct? E to power x minus 7, you're going to shift it 7 units down, so it will be something like that. This is going to be f of x. Is this 1-to-1?
Yes.
Yeah, this is a horizontal line, cross only at one point. Yes. So this is 1-to-1. That means we can find the inverse for this function. Finding the inverse, there's also another word that this function is invertible. Invertible means the inverse is a function, correct, is 1-to-1. So the word invertible that means we can find the inverse. So what is the inverse of this? Can you guys find it?
Is it ln 7x?
Benaz. Okay, let's try. You should be right. So y equal to e to power of x minus 7. X equal to e to power y. Oops. Y minus 7. So that's the first step. Second step is switch x and y. And the last step is solving for this y. Solving takes time. We are dealing with exponential function. So I'm going to add 7 to both sides. It will be x plus 7 equal to e to power of y. How do I solve for y? Our equation is exponential and the unknown is on top, on the exponent. Can I make them same base? No, correct? Now you need to use log or ln of both sides. So because it has e, I will take ln here. Also, I will take ln there. So we have ln of x plus 7 equal to ln of e to power of y. This will come over the front with y ln of e. Ln of e is 1. So y will be ln of x plus 7. So you solve for y. Last step, you change this one. F inverse of x will be ln of x plus 7. Let f of x equal to e to power of x. Solve. F of x to -1 equal to 2. So we see -1 here, but that's not the inverse. We talked about this before. Inverse, the one that we have to go through all the steps, the -1 should be exactly here. That's the meaning of inverse. Here, if you substitute f of x, we're going to have e to power of x to power -1 equal to 2. Then e to power -x equal to 2. Then you solve for x by taking a ln of both sides. Ln here, we have -x ln of e equal to ln of 2. Ln of e is 1. Then x will be negative ln of 2. So we solve. So don't try to use inverse for that. So in chapter 11, which is your last chapter. So chapter 10 was mostly review topics, but we're going to deal with the advanced formula. Chapter 11 is about polynomial. Next Wednesday, we have few people they would like to present, which is great. So I will talk a little bit right now, and then I'll post a video about what you need to know about chapter 11. And Wednesday, I talk more about it, and also a couple people, they will present about polynomial. But mostly the polynomial p of x it will be like ax to power n plus an minus 1, xn minus 1. It goes to a of 0. And it looks ugly. So all the exponent here, so far we know p of x equal to ax squared plus bx plus c very well. Quadratic, we know how does it look like, the solution, the zeros, everything. We also know about cubic, which is ax cubed plus bx squared plus cx plus d. We know a little bit. We know how the graph looks like a chair, the cubic function. But we have no idea about, if I ask you guys p of x equal to x to like 5x to power 16 plus 9x to power 15 plus 3x squared plus 2, something like this, degree 16, correct? But your job is to differentiate, to say yes, that this is a polynomial. So polynomial will be a equation that all the exponent should be an integers. We cannot have negative exponent or fractions. It has to be positive integers. We don't care about the coefficient. Okay, coefficient 5, 9, those can be any number you like. But the exponent must be positive and positive and integers. F of x equal to 5x to power of 4 plus 3x squared plus 9x minus 1 plus 1. Is this a polynomial? So definition of polynomial was all the degrees should be positive integers, and is yes. We have 4, we have 2 and 1, and that's it. Then how many terms do we see here? This polynomial has 1 term, 2 terms, 3 terms, 4 terms. So it has 4 terms. How many coefficients do we have? Coefficients is 5, 3, and 9. The number that multiply by x, they are coefficients. But we usually care about the leading coefficient, the one that multiplies by highest degree. They call it a leading coefficient. And here the leading coefficient is 5. All right. So this polynomial and 5 to power x to power 4, or just x to the power of 4. I'm not going to say they're exactly the same, but they behave same on the long term. If we graph x to power of 4, let's say we're going to get something like that. Not like this, but something like that. And if you graph this one, you might see something like this. 2 different graphs on the short behavior. On the small window, you will see a bump here, but we don't see a bump there. They're different. But on infinity, on positive infinity or negative infinity, both of them, they behave same. They have the same behavior at the infinity. So my point is, limit of this 5x to power 4 plus all everything here, it will be same as limit of x to power of 4 when x goes to infinity. So the idea is in the long terms, on the negative infinity and positive infinity, they have the same behavior. All right, guys, I'm gonna stop here. It's gonna be too much for you guys. So